Hi, welcome to IBM Cloud Certification Series. Today we are going to cover the topic of 12 factors. The objective of this session basically is to make the developer understand how 12-factor methodology can be used to deploy a Bluemix PaaS application and also understand the basics of the 12-factor methodology. Here's the objective as you're looking at the screen and the slide that talks about all the 12 factors that are there, mainly the Codebase, dependencies, config, backing services, build, release, and run processes, code binding, concurrency, disposability, dev and prod parity, logs, and admin process. Before going into what are the 12 factors, we just want to see what do you mean by 12 factors? What is 12 factors? So it is a methodology for developers to follow when building modern web-based applications or software as a service or any apps that are written in any language. Despite being partly self-serving, apps built like this will translate more naturally into running on cloud. There are lots of meaty best practices worth examining. So the key thing this methodology addresses is to have have an outline of how developers can build modern web-based applications. What are the 12 factors? Let's go to the next slide here. What are the 12 factors? So Codebase, I hope I'm going to talk about all these 12 points detailedly in the next slides that are going to come down. First, I'm going to give you a high-level view of what a Codebase is. It's a Codebase that is, I hope all the developers know what is Codebase. Codebase is a version control that people use for maintaining the code. Dependencies explicitly declare any dependencies that are needed for your applications, and configuration. The configuration of your environment variables is what we're going to talk about this and what is the best practice that or the methodology, the 12-factor methodology tells about that. Backing services. How are you going to treat backing services as your attached resources? And the fifth one is build, release, and run, which mainly talks about the deployment and build process of how you can run strictly build your application and run in stages. Processes. What are the type of processes an application needs to be using based on the processes that are available? And port binding. Mainly the services that are externally exposed, or how are the ports that can be exposed using services. Concurrency. Scale out is one of the key things in the concurrency model, so we're going to talk more about that. Disposability is the robustness of the application and how gracefully an application can be shut down when this factor is applied. Dev and prod parity. Is there a need for parity between development, staging, and production, and what are the advantages and disadvantages? Logs. How are logs treated, and how do they need to be used for your application development? And last, the admin processes that we are going to talk about is the management tasks that are involved in administration. Okay, so now we are going to talk about Codebase, which is the first first factor in the 12 factors. So to talk more about this, all of your application code lives in one repository. Once you get big, you may have distributed system with multiple apps talking to each other, like a web application and a backend API, at which point you can treat them as separate apps with their own code repositories, but they are still in source control, of course. A code base is run by the developers on their local machine and deployed to any number of environments, like a set of testing machines and the live production servers. So what Bluemix provides you with is the DevOps services that you can utilize as part of this tooling that provides you. There are deployment tools like Urban Code, Deploy, Gradle, and Jenkins that are there in Bluemix to help you get the same code base for your application. The next slide. Going on to the next slide, this is the view of how Bluemix DevOps services would look like. So you can have your own Jazz source control monitoring tool, and you also can have your own. If you have your Git repository, you can connect to your Git repository. If you want to create a Git repository, you can create a Git repository, and you can also connect to the external GitHub repository if you want to do it. All these are tools that are provided by Bluemix when it comes to the code base. These are all DevOps services in Bluemix. Going on to the next slide about the dependencies. So dependencies, all the environments basically where your code runs need to have some dependencies like a database or an image processing library or a command line tool. Never let your application assume those things will be in a place on a given machine. Ensure that by baking those dependencies into your software system. Most languages and frameworks provide a natural way to do this. You list all the versions of the libraries you expect to have in place, and when the code is deployed, a command is run to download all the right versions and put them in place. So no guesswork here. Everything is as it needs to be. The philosophy extends beyond your developers and DevOps team managing the entire machine configurations using tools like Chef or Puppet or any other tools that are available by the third-party services. So Bluemix adds these external dependencies, gives you an ability to have a build pack mechanism to add external dependencies for you. That is the advantage Bluemix provides in case of dependencies. Next slide, you can see here's an example of a Node.js application where you can define your dependency like cores or J for your application, and Bluemix environment defaultly has that have most of their dependency jars that is already available for use. The third factor in the 12 factors is configuration. Config, basically, this is about storing config in the environment, where what we want to do is store the configuration alongside the application itself. Things like where my particular database lives versus production versus production. Those are also changed as you go along, but that can be tracked effectively. Configuration is anything that may vary between different environments. Code is all the stuff that doesn't. The code that talks to your database will always be the same, but the location of the database, which means where it is running on, will be different for a local developer machine than it will for your production servers. Similarly, in your testing environment, you want to log debugging information about each web request, but in production, that would be an overkill. So what Bluemix provides you with is applications that can be parameterized via system and custom environment variables called VCAP services, and all the environment variables can be stored in those services, not in the application itself. So the next slide in this talks about the sample of how the VCAP services are shown, and a code that gives you an example of how they can be called when an application is bound to a database, or when an application is bound to an Hadoop instance in this case, if you're looking at the screen. So now let's talk about the backing services. This is one of the services that is attached to the resources. So your code will talk to many services like database, cache, or queuing. These should be referenced by a simple endpoint or a URL or by maybe a username or password. They might be running on some other machine somewhere else. So in a different data center. So the point here is your code shouldn't know the difference wherever the services are. It should treat everything in the same way, like what it treats application that's running on the same data center on the same server. This allows great flexibility, so someone from your team could replace the local instance of a MongoDB with the one served on soft layer through some elastic caching mechanism, and your code wouldn't have to change at all. So this is another case where where defining your dependencies cleanly keeps your system flexible, and each part is abstracted from the complexities of the others. So Bluemix provides you with the same mechanism for creating and binding all the services, including the custom user-provided services that you create on Bluemix. There are also multiple services that are available that can be used, and you won't see the difference when you're creating your application. Coming on to the backing services, as we are talking about, so here are different methods where this diagram here shows about how we can bind a service to the application. For example, if we are there's a command in Bluemix that you can push your application called creatorback, and you can bind the service to the FC SQL for that application, and that data SQL service can be residing anywhere. Similarly with the messaging, you can bind the messaging to that push service as well. Now let's talk about the fifth factor here as we went through the backing services. The fifth factor here is build, release, and run. This is one of the process that follows strict build and run guidelines. The process of turning the code into bundle of scripts, assets, and binaries that run the code in the build. The release sends the code to the server in a fresh package together, if you're familiar with the development lifecycle, with a nicely separate config file for the environment. The code is run so the application is available on those servers. The idea here is to build a stage that does a lot of heavy lifting, and the developers manage it. The run stage should be simple and bulletproof so that your team can sleep soundly, basically. If there are any errors, it automatically should determine the errors that are available, and it should make the correction and run well when it is pushed to production. And if the machine gets restarted, let's say a power failure happens, the app should restart again and launch without the need of any human intervention. That is the purpose of this build, release, and run. So the main importance of this is, from a practical perspective, the tools and framework you will define for building, deploying, and running your app will with strict separation of all these layers, would help you a lot when implementing this factor. Bluemix, in this case, has an output and build staging environment that is provided to you by Bluemix environment as well as DevOps, and it has a container by itself. If you're looking at the next slide, you see how the build and configuration are tied in Cloud Foundry with Warden immutable containers, and before they get released onto production. So Bluemix provides you with the inbuilt framework for doing that with build pack and Warden containers in this case. Coming on to the six processes that are there, what we are going to talk about is how an app executes a process, one or more stateless processes. So just take an example. Let's say it's likely to have your application be running on many servers, but what makes it more fault tolerant is that it can support more traffic. As a rule, you want those instances to be running code that are stateless. In other words, let's say that your system is completely defined by databases and a shared storage, and not individual running application instance. That is one of the examples that can help you with stateless processes. So let's say you have a sign-up workflow or some workflow where there are three screens where the information is carried from one thing to another. One incorrect model is to store each immediate state in the running mode and direct the user back to the same server until the sign-up process is complete. So the right approach is to store the immediate data in the database and persist it in a Redis key value store. So if the web server goes down, doesn't matter. In the middle of the user sign-up, there is another web server that can handle traffic, and the system is still aware of the place where you stored stop the sign-up process. So that is never rely on any of the sticky sessions. Let's say when you're configuring any of your load balancers, and don't rely on sticky sessions, and don't design your app in such a way that it follows the stateful mechanism when you're deploying it in cloud. So Bluemix application instances, for example, here in this case, Bluemix provides you with an environment where your applications are stateless, but the state is held by the services. When I say services, can be databases or any endpoint services if you're looking at. So in these, this chart or this diagram shows you the stateless process that Cloud Foundry uses for modern containers. There's no clustered memory or shared file system here. That is the key advantage of the process being stateless, and this shows how Bluemix follows this stateless mechanism for the modern containers and creating an application. Port binding. Here, actually, I think we're going to get a bit more in-depth and technical. This is an expansion of the factor number 4, I think, which is probably backing services. The idea is that you just like all the backing services you're consuming for an application also have interfaces to the endpoint world, like a simple URL that can be published outside. Usually you get this for free because your application is already presenting itself through a web server. But let's say you have an API used by both your customers in the outside world and the internal website you're trusting. You might want to create a separate URL for your API that your website can use, which does not go through the same security or firewall authentication, so it's a bit faster than your untrusted client. The main importance of is most runtimes will give you this for free. If you Bluemix containers, in this case, expose their HTTP port externalized via a certain route. That's how port binding is implemented in Bluemix. So this is typically taken care of by Cloud Foundry components, as it automatically detects and modifies server and service connection parameters so that the application can run and connect to the services without manually specifying any configuration values. As a result, that is developed, it can be tested locally and can work seamlessly on any Bluemix without any code changes. So HTTP port, this means that HTTP port is exposed by the container, Bluemix container. Going on to the next slide about the concurrency. So this is when you're running your code, the idea is to have little process handling specific needs. So you might have thousands of handlers that are ready to process your web requests, and another 1,000 processes that can handle API calls for the enterprise users, and still there might be another 1,000 processes that welcome any of the other messaging processes that can occur in your environment for social media or something. Make sure your applications are small by keeping small parts working independently and running them as separate processes. So your application will scale better. In particular, you should be able to do more stuff concurrently by adding additional servers, CPU, RAM, or taking the full advantage of it through small and independent processes. So scale out via the process model, which means that you create small components which can handle multiple processes, small application components, and have individual VMs scale vertically on those, and have your stateless nature of your application so that it will be simple. What Bluemix provides you in this case is a mechanism to scale automatically using the auto-scaling service that is available on Bluemix, and in case of higher volume, and also following the best practice of designing your application in that executes a little number of processes for a small component, rather than building a large, huge, humongous application that can handle all processes in a single app. So the concurrency, if you're looking at this screen, so first screen on your left-hand side talks about the CPUs that are used by CPUs and RAM that are used by an application. Whereas after the auto-scaling that has been applied in Bluemix, what happens is the scaling of these applications, basically the scaling of the instances of the application are being separated by or scaled by our auto-scaling service, and Bluemix auto-scaling service automatically increases the instance of the app based on the volume that is being sent to an application. So this service helps reduce the problems, the concurrency, if there are lots of high volume transactions that are there. Coming on to the ninth factor called disposability. We're going to talk about robustness, startup, and how your application can do a graceful shutdown, and how your application instances are disposable. So let's take and aim for crash-only design, and whenever don't aim for design that doesn't have any discrepancies in the application or so. So when you deploy a new code, you want the new version to launch right away and start handling the traffic. If an application has around 20 seconds of work, there are a lot of RAM to be used before it's ready to handle the traffic. You made it harder to rapidly release the code, and you introduce more churn out for the system to stop and start the independent process. With this type of approach, so many third-party libraries in today's software systems, sub-second startup times are also available for less common mechanisms. But beyond loading the code, your application should have to do everything that needs to. It needs waiting in high-speed database and cache, using high-speed databases and caches, so it can start up snappily and be ready to serve the request as fast as possible. Further, your application should be robust and against the crashing. That means that if it does crash, it should allow you to be able to start a backup cleanly, and you should have the cleanup task when the app shuts down, which means the graceful shutdown, and that might cause, if that is not handled, that might cause scenarios in your crash scenario. That might cause problems in your crash scenario. So what Bluemix helps you in this case is the Bluemix architecture is designed in such a way that it can rapidly start and stop instances, but also ensures that application can respond at the same time when there is a problem with the instance that is running on, or the long holding process. It releases it and starts. It does it very gracefully for the application and for the end user. Coming on to the 10th factor of dev-prod parity. So we need the main thing. What we are going to talk about is the parity between the development and prod. The name itself suggests that. So keep your development and staging as similar as possible. This ties into the agile software delivery, continuous integration, and continuous deployment type of concept. But really, it's about saying you don't want development or production to get out of kind of skew that one doesn't reflect the other, which means you can't fix one another. You want them to be reasonable and close. So Bluemix Spaces, in this case, provides you with that type of approach where you can separate the different environments. Bluemix has Spaces as this mechanism to support within the same environment. So you can use it for every environment. Bluemix provides you with that capability for that. Now let's talk about the logs, the 11th factor, about treating the logs, and how are you going to treat the logs, and what is the importance of log files. I think we all know what the log files are as being part of the development for so many years. Log files keep track of a variety of things. For example, how your app starts or receiving thousands of errors. In an ideal situation, you see developers in their local consoles and in production, they're automatically captured as streams of events and published to real-time consolidated systems somewhere in the archival or probably somewhere in Hadoop where they capture these. At the very least, you should be capturing all these errors and send them to an error reporting service. Like if there is any error, for example, something like New Relic, that is already available in Bluemix as part of, and also monitoring and logging services that's available in Bluemix as part of IBM service. So basically, you treat your logs as event streams. This is so important. Without correct telemetry in your environment, you have no idea what's going on, and when complex issues come up, that can be terribly hard to fix. Bluemix provides you with the log capability of log aggregator, and that is responsible for logging, and which provides stream of log and output from your application, and also the logs for the when you're tying your services to the third-party you can also tie your logs to third-party management system, log management system with Bluemix architecture. So log aggregator is one piece that has been provided to monitor logs in Bluemix. Here is a sample view of the components that are tied to the log aggregator in the Bluemix architecture and how they are getting tied to the third-party log management system. So system log aggregator is a log to where Bluemix captures all the health monitor, cloud controller, and messaging logs. And all these logs are captured there, and you can also tie them to this Logstash or Splunk or other tools that are available outside for monitoring your logs. The last and the 12th factor in this is in the 12-factor methodology is admin processes. So you should run your administrative and management tasks as one-off process. When you're following this 12-factor admin processes, do not create any admin processes that may be repeated many times and that aren't well encapsulated as code themselves. So it's very important for you to create processes, even if it's one-off process that will do the particular task. And Bluemix provides you with a single shot, the application that can be bound to same services. And also, the main importance of having a console to access the production system is a critical administrative task and a debugging tool. And every major language and framework provides a Bluemix has that capability where you can look at all these services and push the application and see everything in a single shot in this case. And also, example is also written there as we can see that the database migrations are for debugging mainly. If you see any migration aspects, you can. That is one of the admin processes that should be aware of. Just example of that is database migration. Lastly, I want to go to the next slide and see what are the bookmarks available. I assume that we have all the Bluemix bookmarks before anyone came through this section, but make sure you read 12factor.net. That is developed by major cloud leaders in the market, and this is a methodology that has been followed, either it is a cloud-based app or a web app or on-premise app, but this is a strict and stringent methodology that's been followed, and which will return fruitful cost benefit model when it's followed for the long term. Thank you for the 12-factor session in IBM Cloud Certification. Have a good day.